Hello everyone and welcome to the next lesson. In this lesson, we are going to be talking about U-turns and direct left turns if you're driving on the right hand side of the road, and they are direct right turns if you're driving on the left hand side of the road. So you may be asking yourself, why do we need to learn about U-turns when we're doing junction design? Let's have a case in context. So let's look at this area. I've tried to label the different arms for you, that is to say the westbound, the eastbound, and the southbound. And what makes this junction very interesting is that one, you find that there's an area where there's a tram. So if you look at the video carefully, you can see the tram, and they had to design a U-turn because the tram is between both lanes of the carriageway, and they had to design for a U-turn at the junction as shown in green. So you find that there are cases like this where you have a tram and you have to design for the U-turn in that area. Now we also have another case. This is another case whereby you find that again we have the eastbound, the westbound, the northbound, and the southbound. But moving from the westbound to the eastbound, that there is an underpass crossing. And because there's an underpass crossing, you know, when there's an underpass, you kind of limit, you have impact on traffic flow on both arms. And what you're going to find that is that they had to design a U-turn at that point. This is to minimize conflict and ensure that it's safer and easier, and it's highlighted in green. So on that note, let's start off. So normally you're going to find that why do we have to design for these left turns and all, and why do we have to look at them in that case? You're going to find that the areas where we have it's very expensive to acquire the right of way, and because it's very expensive to acquire the right of way, you're going to find that we will have to use U-turns in these cases. Maybe there are any cultural factors or anything along those lines. We could have some consideration regarding U-turns. But you shall find that most of the times when trying to do these direct left turns and all, you could have these issues. Oh, there are some cases whereby you find that you have a very narrow median, like the median is extremely very narrow, and it's not able to accommodate left turn lanes. And in this case, you're going to find that you're going to have to design for a U-turn. Now also there are a number of other cases whereby maybe the speed of traffic is really high, and it would make much more sense to have a direct U-turn. So what are normally the indirect left turn strategies that you can use? If you're driving on the left hand side, it's right turn. What are some of the strategies you can use? One of them is to do U-turns, as we were talking about. We could do median U-turns. The other is something called jug handles. It's what is shown here. That's what you're seeing here. It's just like a jug, the way you hold a jug, and traffic is moving. Again, yeah, we are assuming you're driving on the right hand side, and traffic can come back in that way, that kind of movement. But it's like a jug. And we talk about this at the end, just showing you how it can be designed. And you find that you can also have continuous flow intersections. If you've seen these continuous flow intersections, they kind of try to avoid some of these turns, and they just have continuous flow throughout. Now, the other strategies where you could do stop controlled direct crossovers. And again, if you look carefully in this, you have something similar. So they are U-turns on this other side, because here we're driving on the right hand side. So we have that, and then we have in this other direction. So you can have the U-turns on either side, that is to say around here. Let me just reduce the pen size. So we're driving on the right hand side, so we could have something like this. And again here, because the left hand side could have something like this. So you have these turns, and what they're trying to minimize is they're trying to minimize these left turns for that, for a number of reasons regarding that. So you find that it's much easier in that case. And what you're going to find that is the left turns may be tricky. Okay, so we're going to look at this example here where you find that as cars are moving, because the left turn is not sufficient, you find that some of the cars as they're moving, they tend to veer off. And you find that in most of these cases, you have to use something called a loon. So maybe asking yourself what's a loon? It's just that extra space that is needed to allow for a direct left turn or a U-turn in that case. But most of them will be for the direct left turns. So that extra space that you're looking at right now is what we call a loon. And then you can have crossovers that are placed on both sides. And what are some of these benefits? You can find that when you tend to design the junction this way, you can allow for LRT, light rail, and bus rapid transit because you have used up the median and you can have these kind of turns. And if you've done bus rapid transit designs, you'll realize that this is used a lot, these kind of turns, because the right turns are a very huge problem, or we call them left turns if you're driving on the other side. They're a huge problem on the cycle phase. So they want to have 2 to 3 phases, but if you have these right turns or left turns if you're driving on the right hand side and right turns if you're driving on the left hand side, you find that they end up increasing the phasing and kind of make it inefficient. So most of the times they want to get rid of these right turns, and that's what they tend to do. And you shall find that the crossovers are kept clear of transit vehicles, which is good. And finally, platforms can be moved towards the cross sections, towards the main crossing intersection, which kind of makes it easier. Now, you shall find that when we are doing heavy vehicle consideration, we're mainly going to look at the swept path analysis for this. And what the manual we have used for this case, for this is the Federal Administration Highways Manual. I could have made a mistake, but it's the one that handles, that talks in detail regarding designing left turns and median U-turns. And yeah, you're just mainly going to find that if the vehicle that you're designing for swept paths not enough, provide for that. If it needs more space, add a loon, and that would work out really well. Now the guidelines, of course, I just put this for you just to guide you, and you shall find that one of the things that's recommended is just to have a 12 feet wide. This roughly translates to around 4 meters wide lane. And you shall find that here there are cases, there's a breakdown in regards to different parameters. So what's the minimum width you need when you're designing this that we're talking about? And talk about this U-turn. That's what we're talking about, is what are the different specifications and what's the width that you need for you to be able to design this U-turn. And here there are some specifications, and they're regarding different vehicles, and they suggest what kind of maneuver you're looking at. If you're looking at an inner lane to an inner lane kind of maneuver, or you're looking to an inner lane to an outer lane, because sometimes you want to minimize on space, so you're going to push it to that. Or you want to look at an inner lane to a shoulder. And here they're advising the kind of medians you need to have. Now, of course, this is a starting point, but once you get swept path analysis, and here they're showing roughly 15 to 20 kilometers per hour for this turn. And the bit with this is, once you understand the minimum, you can always draw this. And we draw this in week 2, just to give you a good understanding, but this is a theory. And you can again look at this. Estimating this, of course, if you look at this, it's a very good starting point, and you can estimate how wide that median should be, so you know how wide this taper should be, and in that case. And if we just look at Google Earth, there I've put some case studies here that you can look at. These are some of the U-turns that we're talking about right now. If you're coming something like this, and you're going to an inner lane, a dedicated lane, what are some of the considerations we should have in that case? And that's why I put this for you here, just to guide you in regards to designing this U-turn and what are the considerations that you're going to have. Now, I've also put in a section for signal markings, signing and lighting. This is just to guide you in terms of, we have a course on this, which is a signal one, and also we have a lighting course. But just the markings to make sure that you're designing your U-turns, your markings are efficient. And you're going to appreciate this because sometimes when you're doing these crossover U-turns, do you need signals at those points? And if you need signals, are those signals controlled by one controller or multitude of controllers and all that? Now, for example, that's what you're having here is because you're having these U-turns that are at the end and the west intersection and the east intersection, is you're thinking to yourself, do I need a signal here? And do I need another signal here? And if I need a signal here, what controller is going to control all these signals? Is it going to be one controller, which would be good? But the problem, as you know, is if you have one controller, you find that if just one, maybe you could say phase or signal has a problem, it kind of kills the whole system. Or if they're separate controllers, they can function independent of the other, which I think is something you have to consider. I put also a number of things here for you to consider when you're designing this, the advantages of a single controller and all that. Now, I've also put case studies for you here. All you have to do is get these coordinates that you see here and just paste them in Google Earth. That's what I did here. I just pasted in the coordinates you can see here, and it takes you to a U-turn. And the main goal is try and recreate this in AutoCAD. Get this, measure the dimensions wherever you are. You can come here and you can quickly have a quick measurement of the dimensions, and you say, okay, this is roughly something like 24 meters. This is this, and you draw that. Though we show you how to draw that in week 2. And again, there's some things that we have to look at. And this, I put this as an exhibit. The through turn intersection is where you find that if we are to zoom in here properly, and again, remember, people drive on here, we're looking at driving on the right hand side. So you come and you add what we talked about, a loon. You do the U-turn and you're able to come back. This would be a loon at this section. Okay, and again, you do the same on this other side. Again, traffic comes and can do the same. And you do this also on these other arms. Traffic comes and can do the same, which is a number of areas. And again, as I mentioned, if you have challenges with those turns. So again, it's something similar here is what you're seeing. Traffic comes, goes, and then can U-turn, and then can come back using this. You find these maneuvers, you find that in the area maybe you're constricted. You don't have enough right of way to widen, and then also the other side to widen. So these are some of the interventions you can look at doing. So you find that the U-turns that you have at the different crossovers make it kind of easier. And you remember the main guidance is you're going to face situations where it's really hard to design some of these junctions. And you have to utilize some of these kind of tricks and tips based on your right of way acquisition. Now, I've added something here from the Australian design manual regarding to how you can design the jug handles. And you're seeing this as traffic is coming something like this and then turning round. And here we're indicating, oh, this should be a minimum of this length. And it kind of guides you on regards to how you design this. In the pro tip lesson in week 2, we talk a little bit more in detail regarding this. What are the different factors? What should you look at? And this is why it's very good to look at the different design manuals. You may find in the manual for your country, this is not there. And the challenge with that is some of the African manuals, I know some of these issues are not there. In the IRC, they talk a bit about it, but when I checked, the detail may not have been there, but I stand to be corrected. And again, this shows you how to design the U-turn facility where it's just restricted to standard vehicles. But sometimes when they are heavy vehicles, you may have to do something like this. Most cases where, like in Tanzania, where they had the bus rapid transit, you would see a lot of these jug handle turns, and which make work quite very easy in terms of the vehicles turning. So thanks so much for paying attention for this lesson. I hope to see you in the next lesson. If you have any questions, remember you can reach out to us on Highway Academy, support@highwayacademy.net. Otherwise, hope to see you in the next lesson.